Hello dear children, it's my privilege to present this video session. I hope it will be very useful to you. I am Satyamurthy from Bharathidhasanar Matric Secondary School, Arakkonam. Today I am going to continue 12th mathematics, that is matrices and determinant. In the first chapter, exercise number 1.1, question number 14 I am going to continue now. Listen dears. If A equal to the given 3 by 3 matrix 0, 1, 1, second row 1, 0, 1, third row 1, 1, 0. They are asking you to show that A inverse which is equal to half of 1 by 2 into A square minus 3i. This I represent identity matrix in the order 3 by 3. Listen. In the solution, always first we need to write the given matrix. What is the given matrix? Matrix A equal to, listen to this, very simple, matrix A equal to, that is 3 by 3 matrix 0, 1, 1. Second row 1, 0, 1. Third row 1, 1, 0. So, leading diagonal as 0. So, all the leading diagonal elements are 0. Listen, from this, in the left hand side, I am going to solve first to find A inverse. To find A inverse, we need determinant of A and adjoint of A. Now I am going to find determinant of A. Listen, so to find determinant of A always denoted by double boss. So now you write 0, 1, 1, 1, 0, 1, 1, 1, 0. This is 3 by 3 matrix. In this matrix, in the first element always we should put plus. For the center value minus, again plus. Because what is the place value of this 0? That is A11. So, first row, first column. Now, position of the 0 is A11. So, you add that numbers, 1 plus 1 is what? 2. If we get even number, there will be a plus. If you get odd number, we should put minus. In the second value, 1 is there. That is first row, second column. That is first row, second column. Here, 1, 2, A12. Now, you add 1 plus 2 is what? That is 3. 3 is odd number. If you get odd numbers, we should keep minus. So, likewise, the first row, third column, 1 plus 3 is, that is 4 even number. So, I have written plus. From this, now listen, first consider the 0. First row, first element, 0. 0 into anything, 0. No need to solve it. 0 into anything, 0. Next, minus is there. So, minus 1. So, if you consider this number, we need to omit first row and second column. Completely leave first row and second column. What are the remaining elements? So, there is 1, 1, 1, 0. So, determine these values. So, 1 into 0 is 0. Minus, listen, while we are taking the other diagonal product, we should keep minus. So, 1 into 1 is what? 1. Next, last element plus 1 is there. So, plus 1 into. Now, omit first row and last column because position of that 1 is what? A13. So, we need to omit first row and a third column. From this, so remaining elements is what? 1, 0, 1, 1. So, determine this remaining elements. So, 1 into 1, 1 minus 1 into 0, 0. So, 1 minus 0. Now, simplify this. 0 into anything is what? 0. Again, minus into minus, what will come? Minus into minus, plus 1. So, again, here, 1 into 1, plus 1. So, 1 plus 1 is what? 2. This is not equal to 0. If you get not equal to 0, here, A inverse exists. Do you understand? If you get equal to 0, A inverse does not exist. Do you understand? If you get equal to 0, A inverse does not exist here. Now, I got not equal to 0 because determinant of A is 2. From this, next I am going to find adjoint of A. Adjoint of A is very simple. From this, I am going to find adjoint of A from the given matrix. So, always to find adjoint of A, consider the second row, second element. Listen, what is second row, second elements from the given matrix? So, second row, second element is what? That is 0. Mind it, second row, second element was 0. So, always start with A22, that is position of that 0. So, start with the number 0. So, next number is what? 1. So, starting number 1. So again what we have written first 0. So second row over. Next from the third row, so start with 3 2 place. What is there? In the third row second column there is 1. So start with that number 1. Next number is what? 0. So first element of the third row 1. Again starting element 1. So from the first row second column, so there is 1 again 1. So first element 0. So starting element 1 we need to repeat. So here what we have written in the first row 0 1 1 0. So again you have to write that once again. Sorry, 0 1 1 0. Listen to this. Now I am going to take cross multiplication of this values. Listen, to find adjoint A we need to multiply first row, first element. Listen, from this very simple. Now listen, all of you listen, from this adjoint of A, adjoint of A, this is equal to, listen to this. Now I am going to simplify. From this 0 into 0 is what? 0 into 0 0. So that's it. 0 minus, while we are taking the another diagonal multiplication we should keep minus. So 1 into 1 is what? 1. So 0 minus 1. First row first column over, first row first column over. Next is, listen, so say first row second element. So 1 into 1 into 1 is what? There is 1. So 1 minus 0 into 1 0 minus 0. Listen to this. Next, first row third column 1 into 1 is what? 1 should come, 1 minus 1 into 0 is what? 0 0. Here first row over. Now I am going to start second row. Second row 1 into 1 is 1 minus 1 into 0 is what? 0. 1 minus 0. Second row first element over. Now second row second element, that is second row second column. 0 into 0 is what? 0 minus 1 into 1 1. So 0 minus 1, 0 minus 1. So second row second column over. Listen, second row third element, that is 1 into 1 is 1 minus 0 into 1 is 0. So 1 minus 0, 1 minus 0. Now I am going to do the third row. 1 into 1 is what? 0. 0 minus, sorry, 0 into 1 is 0. So 1 minus 0 again, 1 minus 0 in the third row first column. After that 1 into 1 1 minus 1 into 0 0. So again 1 minus 0. So last row last column, that is third row third column, 0 minus 1 0 minus 1 0 minus 1. Listen, yes. Now I have completed. Now they go first simplify this. The simplification 1 0 minus 1 is minus 1. Next 1 1. So first row over. Second row 1 minus 1 1 plus 1. Third row 1 1 minus 1. So whole transpose. Transpose is nothing but that is interchange of rows and a column. From this I am going to change first row as first column or first column I am going to change as first row. What is first column? Minus 1 1 1. From this minus 1 1 1. Now I have changed first column as first row. So as well as same second column as second row, 1 minus 1 1. So third column I am going to change the third column as third row, 1 1 minus 1. From this is adjoint of A. Now I am going to find A inverse. In the left hand side given A inverse. Listen to this, very simple. A inverse, this is equal to, what is the formula for A inverse? A inverse which is equal to 1 by determinant of A into adjoint of A. From this, listen, 1 by determinant of A. Listen to this, 1 by determinant of A into adjoint of A. From this I can find A inverse. Listen, what is the determinant value? Determinant of A is what? That is 2. Already I have find that. From this 1 by 2 into adjoint of A is what? Adjoint of A. This is the adjoint of A. Now you listen. So minus 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1. So this is A inverse. So the left hand side completely I have finished. Now listen. This is, let consider this is 1. The right hand side they given A square minus 3i. 1 by 2 into A square minus 3i. Within the bracket, what is there? A square minus 3i. First we need to find. To find A square minus 3i, first we have to find A square. So A square is what? We need to write A 2 times. A is nothing but that is given matrix. From this, A square equal to A into A. So 2 times we need to write that matrix. A into A. A matrix we need to write 2 times. So A matrix is what? The given matrix, first one is 0, 1, 1. Second row 1, 0, 1. Third row 1, 1, 0. Listen. Once again, because the A into A, 0, 1, 1, 1, 0, 1, 1, 1, 0. Now, just to take matrix multiplication. In the matrix multiplication is very simple. Listen, in the first row of the first matrix operated on first column of the second matrix. Do you understand what is first row? That is horizontal arrangement numbers. Listen, so these are the 0, 1, 1. This is first row. Operated on first column of the second matrix. In the second matrix is what? Second matrix first column is what? That is 0, 1, 1. So very simple. From this, listen, A square equal to, now you simplify this first row, first column. Listen, yes, from this 0 into 0 is what? 0. 0 into 0 is 0. Next 1 into 1 plus 1. Next again 1 into 1 plus 1. So first row, first column over. First row, first column over. So first row operated on second column on the second matrix. Do you understand? So 0 into 1 is what? 0 plus. Again 1 into 0 is 0 plus. Listen to this. So 1 into 1 is what? 1 plus 1. So first row, second column over. So first row, third column. Next I am going to write first row, third column. So first row operated on third column. So 0 into 1 is 0. 1 into 1 is 1. 1 into 0 is 0. So therefore 0 plus 1 plus 0. 0 listen. Listen to this, 0, 0 plus 1 plus 0. So that is because 0 into 1 is 0, 1 into 1 is 1 and 1 into 0, 0. In the second row operated on first column, the similar method. 1 into 0 is 0 plus, now listen, 0 into 0 is 0 plus 1 into 1 is 1. So second row, first column over. So second row operated on second column of the second matrix. So 1 into 1 is 1 plus, again 0 into 1 is 0 into 0 is 0. Listen to this. So first second row, second column, 1 into 1 is 1 and 0 into 0 is 0, 1 into 1 is 1. So 0 plus 1 into 1 is 1. So second row, second column over. Second row, third column. So 1 into 1 is 1 plus 0 into 1 is 0 plus 1 into 0 is 0. Listen, third row operated on first column. Again 1 into 0 is 0, 1 into 1 is 1, 0 into 1 is 0. From this, so 0 into 1 into 0, 0 plus 1 into 1 is 1, 0 into 1 is 0. Again, so 1 into 1 is 1, again 1 into 0 is 0, again 0 into 1 is 0. Listen, yes. So third row, third column, 1 into 1 is 1, 1 into 1 is 1, and 0 into 0 is 0. Now listen, from this, now simplify this. A square, 1 plus 1, 2, 1, 1, 1, 2, 1, 1, 1, 2. This is A square, and A square minus 3i is there. So I is already said, that is identity matrix. Identity means what? That is in the leading diagonal of unit value, that is 1. Other elements are 0, that is called unit matrix. From that 3i I am going to find now. 3i equal to, so 3 into identity matrix. This is the already given matrix is 3 by 3 order. So same thing I am going to write in the 3 by 3 order matrix. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Now listen, so in the leading diagonal elements are same, that is 1. If you get equal to 1, that is unit matrix. Listen, so 3 multiply within the matrix. So multiply with every element of that identity matrix element. Listen, 3, 0, 0, 0, 3, 0, 0, 0, 3. So this is 3i matrix. Now in the right hand side they given 1 by 2 into a square minus 3i. Same thing I am going to write 1 by 2 into a square minus 3i equal to, listen, yes, 1 by 2. A square matrix is what? A square matrix is 2, 1, 1. Listen, from the second row 1, 2, 2. Third row, sorry, the last element is 1, 2, 1. So 1, 1, 2. This is A square matrix minus 3i matrix is what? Minus 3i is 3, 0, 0, 0, 3, 0, 0, 0, 3. Listen to this. So already in the outside 1 by 2 is there, 1 by 2 into, now you subtract, because they given in the subtracts. So subtraction very simple. So we need to subtract the corresponding elements. Listen, 2 minus 3, 2 minus 3 is what? Minus 1. So first row, first in the first matrix first element minus the next matrix first element. So 2 minus 3, 1 minus 0 is what? 1. 1 minus 0, 1. From this, next 1 minus 0 is 1. 2 minus 3 is what? Minus 1. 1 minus 0 is 1. 1 minus 0 is 1. Again 1 minus 1 is, sorry, 1 minus 0 is 1. Listen, 1 minus 0 is 1. 1 minus 0 is 1. 2 minus 3 is what? Minus 1. So let us consider this is 2. Now you see 1 and 2. A inverse is 1. And right hand side 1 by 2 into a square minus 3i is 2. Now you check this whether both are, check 1 and 2 whether equal or not. Listen, 1 by 2, 1 by 2. In the first row minus 1, 1, 1. Second row 1, minus 1, 1. Third row 1, 1, minus 1. Same thing. So from 1 and 2 both are equal. Ends the proofs. Therefore from 1 and 2, from 1 and 2, A inverse which is equal to 1 by 2 of a square minus 3i ends proved. Dear students, below this video we have given study material, self assessment question paper and a question bank and YouTube link PPT. So go through it and write self assessment test and send it to the school WhatsApp. Thank you.